Hi, my name is Ron Dorn, and I'm in my storage room for our grandbaby. That's what the supplies, that's what you're looking in the background. I'm I'm making this recording with the sole purpose of having you feel comfortable measuring distances in the Grand Canyon Grand Lab using the Pythagorean Theorem, and also show you how to do fast travel. But there's another presentation to show you how to do fast travel in the game. So I'm going to start trying to share my screen, and you should be looking at the landing place where you start the game. So I'm in the game environment here, and I'm hitting escape button to give myself control over the menu. And then when I hit escape again, I can move the mouse around to change the view of the game. If I want to scroll back in the game, to remind you, I use the mouse to be able to pull back or to zoom in and to change the camera angle. So it's the mouse control that changes the perspective of the camera and what you see. But that's not really the focus of this presentation. What it is how to use the Pythagorean theorem. So I'm going to first bring you to the fast travel menu and see this inset map in here. One way you can use the fast travel is to simply click on the map. So I'm going to click on the map pretty much where the south rim is here. I just know it pretty well. When I clicked on this button, notice that the fields of latitude and longitude populated. So if I click on it again, so I'm going to click on the fast travel button, and boom, I'm suddenly at a location that is pretty close to the south rim. I'm going to leave it right here, and then I'm going to take a screenshot to preserve what you see on the screen of the latitude, longitude, elevation, and the X and Y coordinates, because I want to have those handy. So a screenshot on a Mac is a short key command that's explained in another presentation. And I want to preserve these coordinates here. All right. So now that I have these coordinates and you're seeing where the avatar is in the inset map, how do you figure distances as the crow flies? What's called planimetric distances. What I'm going to do is take the distance in meters from the lower left-hand corner, the southwest corner of the game board, which is 0, 0, 0x, 0y, and explain that there's the meters that you see in the screenshot and in the game board. You are 20,989 meters in the X direction, and then 16,450 meters in the Y direction. So there's two arms of a right triangle. How do you then measure the distance between this location and where the avatar is right here? In some computer programs, there are tools where you just draw a line and the distance is automatically measured. But this is a lab science class in geography that has to employ math. And so what you're going to learn in the context of doing this lab is something that's needed for a lab science class where you apply math and it's used in science. And the Pythagorean theorem is used a lot in science in making measurements. We measure distances on the ground or of a tree height or of a building height, and the concept is the same. So what I want to do is bring up a search window, and I'm going to type in Pythagorean theorem calculator in Google. So, oh, it's in YouTube. Sorry, I need to move to google.com. Pythagorean Theorem calculator. So in Google, it brings me the Pythagorean theorem that I'm sure you remember from middle school and high school is the distance of the hypotenuse is the square root of one leg of the triangle squared plus the other leg of the triangle squared. So let's enter the x and y coordinates. So the question is, what's the distance between 0, 0 on the game board and the location on the map? So one leg of the triangle is 20,989. The other leg of the triangle is 16,450. I simply hit return or enter these things in, and the distance in meters as the crow flies would be 26,667 meters, or let's round up to about 27,000 meters. You're going to be practicing using the Pythagorean theorem and its calculator in stage 0. This is just a shortcut to explain that it's actually pretty simple, hopefully. Enjoy. Now I need to stop this thing. Here we go. And end.